how to go from acceleration to displacement. So as you know that the shaker is vibrating sinusoidally at a frequency of 159.2 hertz. So if I do the math here, this is the sinusoidal wave equation. You take the velocity by taking the time derivative, which gives you minus a omega sine omega t. By the way, a sine omega t is also equivalent to a cosine omega t because both are the simple harmonic motions. Then you take the second derivative to go from velocity to the acceleration. Now in this acceleration term, if you go over here, if you do rearrange it, you see what is this? This is equation 1. And from here you just replace a cosine omega t by x, and this is the displacement. That's what we want from our lab 1, the graph for displacement from the acceleration, where omega equals to 159.2 times 2 pi, which is 2 pi f obviously. And then we can find out the acceleration dividing by omega square. So that's how you do it. So let's do this in the MATLAB. So if I import the data, it will prompt you to pick up the data from lab 1. So let's see. So if you pick up the data from your lab 1, first of all you replace this table to column vectors, and you just need this first and second column, so you don't need the third one. So I will say just put B over here, so this highlights the values, and this first column is the time, second column is the acceleration 1D. Suppose this is one dimensional data. So now you import it, and once you import it, you get this in your time versus, let me double check if everything looks good, and time versus acceleration d. Let me double check acceleration d. Yeah, now I got the acceleration d over there. So now what you have to do here, you have to go here, clear the screen, and then you have to plot the time versus acceleration d, just to see how it looks like. So it looks like this. This is a part of your lab actual graph, so you can see you must label the x-axis as the time in seconds, the y-axis as the g value. And now if you want to convert from acceleration to the displacement, what you have to do here, divide by omega square, so negative omega square. So if I go to the displacement, so where omega, let me check it, this is omega, which is 2 pi f, and x displacement is negative 1/2. This is what. So now you take another, maybe you can do a subplot of 2 by 1 by 1, 2 by 1 with 2, which because 2 rows, 1 column, and the second place. So then it will show you the plot and time versus x. We need to do the velocity first. So let me check displacement. Let's do the displacement. So plot time versus displacement. Yes, let's do this. So now this is my displacement. As you can see, this y-axis is just like a micrometer, which is true that the shaker was moving very low amplitude. Now the top figure, you can put the subplot, and the first 2 rows, 1 column, and the first place it will take the first column. You have to label it by x label, y label. You can Google how to label a MATLAB plot, and then plot the time versus x. This is our, you have to show me like a zoom in portion. I want to see the trend. Okay, this is how you do that. The first one is the time domain acceleration signal. The second plot is the time domain velocity signal. Time domain the displacement signal. Now if you want to go for the velocity, you can check for velocity. You have to divide by 1 omega the same data, and then you can make another figure here, plot time versus velocity here. So this is how you do the velocity, and which is about millimeters per second, like about 1 millimeter. That's how you complete your exercise.